Hi guys, and welcome to this, my video on solving linear equations, part of the Year 9 Maths course, well actually part of every course, because solving linear equations is critically important for this in Year 9, 10, 11, 12, and into university, although then I imagine it becomes so conceptual. Now, my name's Darren from Maths Guru, yes, Maths Guru, my little corner of the internet, where basically you can get all of these videos sequenced against the Cambridge textbooks, downloadable lesson notes, everything you see behind me, I'm actually going to give you as a PDF, exam questions and such moreover. It's absolutely free to sign up. But before I go, can you do me a massive favor if you're new, and even if you're not new, can you subscribe to my YouTube channel? Sounds very needy, I know, but nobody watches maths videos. The fact that you're watching this, I don't know how you stumbled across it really, but the fact you are watching it, every time someone clicks subscribe, it really does mean the world to me. So often I sit in this room talking to myself going, there's no point doing this. And then I get sort of 10 people sign up and go, no, it's really useful. Thank you very much for doing it. Right, enough of the whinging from me. Let us move on to the learning objectives. Now, obviously, what I would normally do is talk over that. But hey, it's a video. You can pause it if you want to read. But it's building on the stuff that I have done previously. And yes, again, there are videos on mathsguru.com that already does this. So, you know, it's really, really important. As I say here, solving equations, and I can't do the whole idea. I can give you an indication of how to solve them, sort of the main steps, but it gets a really big topic, and this video will probably go about 4.5 hours long. But as I've said, in previous videos, we found ways to expand brackets and algebraic expressions, collect like terms, multiply and divide terms, and simplify expressions. All really, really important. We're going to move on to the idea of equations, but linear equations. And as I'm going to say in a moment, linear actually has the word line in it. All right, so all the equations you're about to see give you a straight line. Later on in the Year 9 course, we deal with linear relationships, which are straight line graphs. And again, if you can identify what a linear relationship is, you're going to smash the rest of this course. Now, what is a linear equation? All right, it's going to give us a straight line. If you put all of these equations into a graphing program, for example, I don't know, desmos.com. If you don't know what that is, and I am not affiliated with them in any way, shape or form, but if you go over to desmos.com/calculator, you can actually put all of these equations in there and ultimately, well, no, actually, I don't know that you can, because what you'd have to do is ignore the equal sign. If you put all of these things in here, if you put all of the things before the equal sign into Desmos, that will actually work. As soon as you make them equal, something pretty funky happens. But again, I'm going to leave that to one side. But these are all linear equations. How do I know they're linear equations? Because, well, if I look at the floaty power of x, if I look at the x term, and we now know what a term is, we notice that all of those have, well, you're going to say no power. Well, actually, it does have a power. It's a floaty 1. And where you have the highest power in an expression or an equation that is a 1, it will be linear. Right? It will always give you a straight line. So all of these here will give me straight lines. That's why they're called linear equations. Now, when we put a expression, say, for example, 2x plus 3 equal to a number, when we are putting it equal to a number, we are finding a specific solution. And I'll talk a little bit more about that a little bit later on. But what we're trying to do here is say, well, what value of x, when I times it by 2 and then add 3, gives me 4. Now, those of you out there who are like, well, you're probably trying to backtrack it in your head, aren't you? You're trying to say, well, oh, okay, so what can I do? Take away 3 from both sides, divide by 2, and you're going to get some sort of value, yeah, here, or you might be turning around and trying to guess. You might let x equals 1, x equals 2, x equals 3, and try and guess and check that way. All valid ways, absolutely, but guess and check is going to take a long time, and there's got to be better ways of doing it. So, yes, I'm going to talk about the idea here of backtracking, of doing things backwards. But I have 2 rules here, that when something is stuck to the letter using a kissy, and there are videos on all of that kissy stuff elsewhere, when a number and a letter are stuck together, leave them till the very end, all right? I call them the kissing couple. I'm so sorry. Kissing? Swapping bronchitis? Gross. But the point of it is, you leave those until the very end. Yeah, then you separate them. It'll make life a lot easier. Also, if you have bunk beds, a division sign, and again, I'll talk about bunk beds in a different video, then again, you leave those till the very end. And there are rules that you follow. And if you follow the rules, you're going to smash this every single time, I promise. So let's have a look at some examples. It's the best way we can do it. And I'm going to do them one by one. Again, you can download these notes from mathsguru.com, which is, again, absolutely free to sign up. But this is what I do. When I do these, I do 2x plus 3 equals 4. Now, I can see that the 2 and the x are kissing. Leave them alone. Between there is a times. A times sign looks like a kiss. We'll leave that on there. I want to leave those till the very end. I am going to get rid of anything that's connected by a plus or a minus first. Now, that's in this situation. Later on, we get to divide, new story. But what I want to do now is get rid of a plus 3. Well, how do I get rid of a plus 3? Well, ultimately, I want to undo it. I want to do it backwards. So I'm going to take away 3 from both sides. And with maths, what you do to one side, you have to do to the other to keep it level or equal or whatever else. So now when I take away 3, that's going to disappear, the whole point of doing it, leaving me with just 2x on its own. And then when I do 4 minus 3, I'm going to get 1. Right, is there any more pluses and minuses connected to that? No. Right, well now I've got the kissing couple. What I want to do is separate the kissing couple. And again, I remember that 2x is the same as 2 times x. So here is a times by 2. How do I undo a times by 2? I'm actually going to divide by 2 on both sides. So I'm going to divide by 2. Now when I do that, the whole reason I do that is because when I divide that by 2 and divide that by 2, this 2 on the top and that 2 on the bottom, they cancel each other out, but what they really become is 1s. So I get 1x divided by 1, which is just x. Right, so there we go. So that gives me x is equal to, well, 1 on 2 is a half, and believe it or not, I've just solved my first linear equation. And no one said that you weren't going to get fraction values. I know a lot of you out there love whole number values and think it's horrible if you get a minus or a fraction. But if it's a nice fraction, like a half or a third or things like that, it's fine. We like fractions. Please get used to them. They're going to be everywhere.